In this collection of videos, we are going to review or have an introduction to some facts that we will need from probability, and then we'll have a discussion about how we go about finding an optimal scoring function, just as we did when we did linear regression and we discussed how we were going to use that residual sum of squares to find our line of best fit. So I do want to start with probability. If you are a very strong probabilist, then this will mostly be for review for you. If it's been a while since you looked at probability, I'm just going to cover the things that we need in order to talk about what we're going to define later, which is the likelihood function for logistical regression. So I want to think about something that would come out of a standard probability question, which is, suppose that I have a normal, fair, six-sided die, and I've got a standard deck of cards, 52 cards, with 13 cards for each of the 4 suits. And I want to know, what is the probability that I both roll a 6 and pick a 6? And there's lots of different ways to think about that, but I know the way that I learned to think about these sorts of things were to think about all of my choices and to try to create some visuals that help me visualize those choices. So I learned something called tree diagrams, which I've drawn for you right here. So the tree diagram, the root of the tree is just sort of an abstract point, and then you draw branches for all of the different choices that you have. So for example, I've drawn in branches here to represent the different options I have when rolling that six-sided die. And the branches I've drawn are equally likely. So it is just as likely that I roll a 1 as I roll a 2, as I roll a 3, all the way on to rolling a 6. And I've highlighted that the only case here that would even give me a remote chance of being successful for my overall question is rolling a 6 with that die. But of course, rolling the die is just one part of what I'm doing. I'm both rolling a die and picking a card out of a standard 52 card deck. So the next level of the tree diagram is to draw in branches that are all equally likely for all of the possibilities that could arise from my 52 card deck. So here I've taken a little bit of leniency to not draw all 52 branches, but let's envision that off of each one of these branches from the original source of the tree, I now have 52 more branches coming in this direction. And then I've highlighted one of those options that would satisfy the overall problem right here. And I haven't bothered filling those things in for the other branches because all of them have already lost out on satisfying the case that I'm looking for because I haven't rolled a 6, and that's part of the deal. So if I were to go ahead and count the number of total leaves on my tree, which would be all these tiny little points that are here at the bottom of the tree, then I would have 6 times 52 leaves, and that would be the total number of possibilities, and I would compute the probability by counting the number of red leaves on the tree when all of the leaves are either blue or red. Now, another thing that you might have seen, because the tree diagram prior to this was very busy and very difficult to actually visualize what I wanted to do because it was so busy, is a lot of times we condense things into the situation I care about and the situation that I don't care about. But when we do that, we're breaking the symmetry that every branch weighs the same or is equally likely. And so if you're going to just have 2 branches, things that satisfy what I'm looking for and things that don't, you need to have these little markings for kind of how much weight we're attributing to those branches. So overall, I had 6 possible choices at this level of the tree, only one of which led to the desirable outcome. And then there were 5 other branches that I'm condensing down into just this losing branch. 5 out of 6 of them were losing branches. And then I can do the same and actually truly visualize my choices, just acknowledging the different weights of the branches that I have moving forward. I have 4 of my 52 cards that have a value of 6. 48 out of 52 of them are not a 6, and similarly on this side of the tree. So if I were looking for the total probability that I roll a 6 and pick a 6, what I do is multiply down the branches of the tree that lead to my desired outcome. So that's the beginning of our review of probability that we'll need for our logistical regression.